Hello everyone. In today's talk, we will learn how to convert Cartesian coordinates into polar coordinates. But before that, we also must know what is the need for that. So far we have studied in quantum problem of 1D box in which the motion of the particle was in a straight line, that was translational motion. In the vibrating particle, the particle was vibrating and we had calculated the energy in that terms only. But when it comes to atom, we have to deal with electrons. Electrons are revolving around nuclei, we already know, and they are following a circular trajectory, or I must say it is a spherical trajectory. So they are forming, their path is forming a sphere. It means we can say the electron is moving on the surface of a sphere. So if I need to solve Schrodinger's wave equation for a electron inside an atom, so I must know the Schrodinger, how to write the Schrodinger's wave equation in polar coordinates or spherical coordinates. Alright, so this here comes the need of spherical coordinates. Now there is a difference between spherical and polar coordinates. Sometimes we use word polar coordinates. In polar coordinates, we have only two-dimensional surface in which r is considered, which is the distance of the particle from the origin, and second is theta, which the angle that position vector is making with z-axis. Only two variables are there, r and theta. And in spherical coordinates, we have three variables, r, theta and phi. So we collectively call them spherically polar coordinates. So let's see. The Cartesian coordinates are x, y and z, we already know, and the spherical polar coordinates are r, theta and phi. So these two are polar coordinates, and if I include phi, it becomes spherical coordinates. Alright, so we can say polar coordinates also if phi is kept constant or like that. So now comes the point. Here I have drawn this diagram. Z is this side, y axis and x axis. We have these three axes, and we assume that the nucleus of the atom is lying at the origin and the electron is revolving around the nucleus through this path. Okay, so it's in 2D surface it's a circle, but in 3D it will be a sphere. So electron is moving on the surface of a sphere. So at any time t, I assume that the electron is present here somewhere. This point is on the surface of this sphere. Alright, so the distance from the origin to this electron will be r, and this is a vector quantity. Alright, in Cartesian coordinates, the position of this point will be x, y and z. Right, and we have a relation. The vector r can be given as xi cap plus yj cap plus z k cap. This is the relation between the position vector and x, y and z, their Cartesian coordinates. If I take magnitude of r, this will become r square is equal to x square plus y square plus z square, or r is equal to root of x square plus y square plus z square. Alright, now we have to find out x, y and z in terms of r, theta and phi. R, theta, phi. Here also some another function which is r, theta, phi. Z also has to a function of r, theta, phi. So we have to find these three. So let's see this picture clearly. The position vector is making angle theta with the z-axis. Projection of this position vector is on xy plane, and which is making angle phi with the x-axis. So we have to consider only these three triangles which I have marked in red color, this green color and blue color. red, green and blue. Right. So in first triangle we have this angle theta with the z axis, z becomes the base and r is its hypotenuse. Second right angle triangle is this one, when the projection is falling on y axis and this is the projection, and if we draw perpendicular here, this will be right angle triangle. So right angle means this becomes perpendicular and this projection is its base. So base is, let us say it is alpha. Again hypotenuse of this triangle will be r and this is perpendicular. So let it be like this only. In third triangle, phi is the angle with making which the projection is making with x-axis. So with x-axis angle is phi, its perpendicular is, here is the right angle and the perpendicular is y, and hypotenuse we have to find. Okay, this. All right. So this is the base. Okay. So its base of this triangle becomes hypotenuse for this triangle. Yeah, this was right. Alpha over here. Or I can say alpha over here. So let's calculate from this triangle. We have base and hypotenuse. I can say cos theta is equal to z upon r, or z is r cos theta directly. The first one. Second, from the second triangle, again I have base and hypotenuse. I can say cos of 90 minus 90 degree minus theta is equal to alpha upon r, or value of alpha will be r sin theta, because 90 minus theta comes in first quadrant. In first quadrant all the angles are positive and sine will be converted, cos will be converted to sine. This is the value of alpha. Now come to this third triangle. From the third triangle we will have sin phi is equal to y upon alpha and cos phi is equal to x upon alpha. If I substitute the value of alpha over here, I will have y upon r sin theta. Hence y will be r sin theta sin phi. Alright. Similarly over here also x upon r sin theta. Hence x becomes, multiply this term over here, r sin theta cos phi. So we have the value of x, y and z in terms of cos theta, phi and r. So Cartesian coordinates are converted to polar coordinates. So we will use these relations wherever it will be needed in our further derivations.